section 1.3, evaluating limits analytically. Sometimes limits are continuous. What does that mean?
Forever
Just
stop.
keep going and going and going. That means there's no breaks, there's no asymptotes. The graph just keeps going and going and going, which typically is a polynomial. Just a regular old polynomial, goes on forever and ever, and its limits are very, 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 very easy to compute. So what we're going to do today is talk about some tricks and some patterns and some really basic limits, starting with this one right here. Number one, the limit as x approaches c, and that just means as B and C are real numbers right here, as I've written. As the x value is approaching some real number, the limit if it is approaching b, the answer is going to be b. And what I mean by that, for example, is that if you are calculating the limit as x approaches, say, 5, and the function that I give you is just some constant number, you're going to have, for example, if it's 7, you're going to have a horizontal line at 7, and regardless of what value of x you're approaching, you are always going to get an answer that falls on that line. So it's always going to be 7. So if I was asking you guys for the limit as x approached 5, but this was not a 7, let's say it was a 10. If it was a 10, what would the limit of 10 be if x was approaching 5? It would be 10. Okay? Joey, your hand is up.
Okay.
Okay. I'm just trying to make it work for my money.
I was gonna nitpick that one.
Thank you. Number 2. The limit of x as x approaches c is equal to whatever the c value is. So we need to talk about that function, x, right here. That's a horizontal line, not a horizontal line. That is a diagonal line. I don't know why I just said that. That goes right through the origin, right here. Falls right there. And on that line, every x value equals its y value. X's and y's are equal. That line right here is the line y equals x. So if you take an x value, what's y? Well, it's exactly the same as the x value that you chose. So if you are finding the limit of just x, as x approaches c, the answer is going to be c. So for example, if you have the limit of x, as x approaches 2, the answer is going to be 2, because as I'm getting closer to an x value of 2, from this direction and from the left direction, you're approaching the exact same y value. These 3 are pretty darn easy. Third example, the limit of some x value put to the n power, which is why above I had noted that the n value had to be greater than 0. This is only true for positive values of n, positive powers. If you are taking the limit as x approaches c of some x to a power, you will get the same answer as you would if you just took this c value and you put it to that exact same n value. So, the limit as x approaches 2 of x cubed, all you have to do is take that value of 2 and put it to the exact same power. You put it to the 3rd power. Now, if you are working on an assignment and you're like, oh my gosh, which rule do I use? These are just common sense rules. If I give you some polynomial, x to the 7th power is the polynomial I give you, and I ask you to calculate the limit, all you're going to do is put that value right in for x, and you're going to calculate its answer, because this is what kind of a graph? We wrote it above.
Continuous.
It's a continuous graph, and if they're continuous, all you have to do is just throw the x value in for x, and you're going to get an answer out of it. So don't stress out about all of these things. These are very kind of common sense rules. All right, moving right along, page 2, properties of limits. B and C, I've made it out here, B and C are positive numbers, and the n value is greater than 0. Again. This says scalar, SC like you're scaling something. So I give you two limits. The limit as x approaches c of f of x. The limit as x approaches c of g of x. And we're just going to say that the limit of f of x is equal to L.
Bless
And
you.
the limit of g of x is equal to k.
Can you go to second grade?
So you can listen as I speak.
Yeah.
I'm fine with that. Scalar S-C-A-L-A-R. Alright, so in the property called scalar multiple says that if you take the limit as x approaches some number c, that is the same, you will get the same answer if you multiply the function by b and then calculate the limit, or if you find the limit of the function first and then multiply the limit by whatever the scaled number is. So this b out front would be, for example, let's say that f of x, I'm going to keep this really simple. Let's say that f of x is equal to 2x plus 1. And you had to figure out, well, no, I said, what is 2 times f of x? Well, 2 times f of x would be 2 times 2x plus 1. Well, 2 times 2x plus 1 would be 4x plus 2. So you could just find the limit of 4x plus 2. Or you could find the limit of the original function, 2x plus 1, take your answer, and multiply your answer by 2. That's what that means. Make sense?
Yeah.
Can I erase what I just wrote here?
What?
Okay, no, I'm not going to. I will do it in a minute. Summer differences. All right, the limit of x approaches c of f of x plus or minus g of x. All you need to do is calculate the limit of the first function. You can calculate the limit of the second function, and then you either add them together or you subtract the two limits. So rather than actually adding the functions together first and then calculating the limit, you can calculate the limits individually and just add their limits together in the end. And you will probably just figure this out as you go. Some of you may choose to find the limits individually and add their answers together. Others of you may choose to add the polynomials together first or subtract them and then calculate the limit at the end. You will figure that out, what technique works best for you as you're working on this. All right, product. The limit as x approaches c of two polynomials multiplied by each other, f of x times g of x. All you need to do is take the limit of the first one. Remember we said the limit of f of x we called L. The limit of g of x up here we called it k. All you have to do is take their limits and multiply them. That will get you the limit of the product of those two polynomials. Number 4, the quotient.
Wait, so I
Can
don't.
you scroll up?
Hold on.
I didn't get to the
Can
part.
we go back to project?
We can't see.
When would you be doing this?
If I told you to find the limit as x approached some c value of some function multiplied by another function. So if you had two functions, I said multiply them and calculate the limit, you could do one of two things. You could multiply the functions first and then calculate their limit, or you can calculate the limit of one of the functions, calculate the limit of the other function, and just multiply the answers together. Either way is going to get you the same thing. Do you want me to show you an example?
Yes.
Yes. Okay. All right. Let's say you,
Is this an example for product?
for product, yeah. Let's say that f of x, I'm gonna keep this simple again, f of x is equal to x, and g of x is equal to, I'm gonna go back to my 2x plus 1. You could do this. You could multiply these two things, f of x times g of x. You could go, okay, well, x times 2x plus 1 is equal to, and then multiply them. If you were to multiply them, you have to distribute the x in, getting you 2x squared plus x. You could get that, and then calculate the limit. Or you could calculate the limit of f of x, calculate the limit of x, calculate the limit of 2x plus 1, get an answer for this one, get an answer for this one, and then just multiply them. Either way works, okay? All right. The quotient property, same thing. You're just dividing instead of multiplying. So the limit as x approaches c of f of x divided by g of x, all you need to do is take the limit of 1, limit of f of x divided by the limit of g of x, get an answer. Pretty basic rules. By the way, why does it say k not equal to 0?
You can't divide by 0.
Yeah. If you get a limit of 0 for g of x, then you can't do this. It's not gonna work. So you have to explore other options there. The power rule, if you have the limit of as x approaches c of some function to a power, all you need to do is calculate the limit of the function and put it to that power, and there's your answer.
Is that a 7?
Is that a what?
A 7? Number 5?
A 7?
There's a
F
N.
of x.
What are you talking
Oh, it's an N, okay.
This right here?
Yeah.
I need to practice my ends, is that what you're telling me?
No, he just can't read it.
You're good.
We're gonna stop right here. Examples. All right. The limit as x approaches 3 of 5x times x plus 4. And this would be the product rule that we just talked about. You can calculate the limit of 5x as x approaches 3, get an answer for that, and multiply it by the limit as x approaches 3 of the other function, which is x plus 4. So I'll give you guys a second to punch up here. All right, so I've written this out. We have the limit. The limit as x approaches 3 of 5x. I'm going to do this part, in other words, I'm doing this part individually. And I'm going to multiply that by the limit of x plus 4 as x approaches 3. I'm going to do them individually, and I'm just going to multiply. I'm going to multiply the limits, the answers when I'm done. But because these things are both polynomials, all I need to do is take this value that it's approaching, and I need to plug it in for x. So really all I'm doing here is taking 5 times 3. 5 times 3 is 15. I'm multiplying these limits, so I have to put a times sign here. Then I take this x value of 3, I plug it in for x. So you're really just going 5 times 3 is 15. 3 plus 4 is 7. I'm multiplying those two answers and getting 105. 2, the limit as x approaches 2 of 4x cubed over 2x. Again, I'm going to do each one of these things individually. I'm going to do the limit of the first one. Notice my divide sign, I'm dividing by, and then I'm going to do the second one. Now some of you might be wondering, why is this 4? Why is it brought up front instead? Why is it not just part of the rule? This 4 will work just as well if you leave it in here, but there was a property that we talked about at the very beginning called scalar multiple. I think it was the very first property that you wrote down. Scalar multiple says that you can just calculate the limit and then multiply it by whatever is the scale number. In this case, the scale number would be 4. So the limit as of x to the third power as x equals 2 just means that you need to take this 2, you need to put it in for x. So we have 2 to the third power, which is 8, and then you multiply it by 4. 4 times 8 is 32. So this right here is 32. And then you have to divide that by,
I know.
divide it by, here's your multiple, your scalar multiple, 2. And then this thing right here needs to get plugged into your function. So you're taking 2 times 2. What's 2 times 2? 2 things multiplied is 4. 32 divided by 4 gives you an answer of 8. Now, for those of you going, what is she talking about? This seems so confusing. You know what? It sounds confusing. I am writing out every single step. I promise you guys, you're going to get in your groove, and these are all polynomials. And what you're doing is calculating the limit of one, calculating the limit of another, and then multiplying your answers, or you're dividing your answers, or adding your answers, whatever the case is. So I put a little note here, and you can write this down, or write this down if you don't want to, but really all you're doing here, can I erase all my chicken scratches here?
Can you please hold up? No, it's
Wait,
for a
wait, wait.
minute. One moment.
I can get rid of them?
No.
Okay, no. Okay. Hold on 1 second, okay? You could just do this. Here's the original function. You were finding the limit as x approached 3 of 5x times x plus 4. The x value is 3, correct? This is just a polynomial. It's a continuous graph. So there's no tricks or anything else. All you need to do is take this 3 and you need to plug it in for each of the x's. And then you just calculate the answer. So I wrote it out as 5 times 3 multiplied by 3 plus 4. 5 times 3 is 15. 3 plus 4 is 7. So you're just multiplying 15 times 7, which is 105. Does that seem like way more doable?
Yeah.
That's what you're doing. I want to show you what you're doing and what laws and what properties are behind all of that. But this is all you're doing, so don't get nervous and mad at me yet. This one right here, same thing. All you're doing is plugging a 2 in for x, plugging a 2 in for x. You're calculating the top, and you're dividing it by the bottom. Do you still have something to say, Joey? Or
Isn't the second one the quotient one, not the scalar one?
the second one?
Yeah.
You said it was the scalar one, and I was like, what?
No, it is the quotient one. You are definitely dividing, but do you see how I brought this 4? See this 4 right here? I brought it in front. That's what I meant by scalar. So this actually is a combination of both quotient and scalar. Okay, I'm going to erase now. If you didn't get it all, you can get it from me later, or you can copy somebody else's.
Can you just move the substitute thing up a little bit?
All right, the limit of a composite function. Is this our last page? This is page 3.
Oh, my God.
All right, the limit of a composite function, if f and g are functions such that the limit of g of x is equal to L, and the limit of f of x is equal to f's value at the limit of g, then, scroll that on here. The limit of f of g of x as x approaches c is equal to f times the to f of L. Are you okay with that?
No.
Totally.
Okay, great, let's move on. This, I get this right here, this will be the most confusing thing I tell you today.
Can we write it and then?
Yep, write it, and then we'll talk. And I also want to say that when you get these kinds of problems in your book today, it will walk you right through the whole thing.
Wait, did that say X of C under F?
X approaches C. Yes, X approaches C.
Is that C or E?
C.
No, I just connected to the Bible.
I would type it anyway because all this stuff to type is for you on this. All right. An example. F of x. Can I scroll down more?
No.
F of x is equal to x squared plus 4. G of x is equal to the square root of x. Now, if I asked you to calculate for me the limit of f of x as x approaches 0, because f of x is a polynomial, a continuous graph, all you would need to do is plug this value into the function. So you'd have to take this 0, you'd have to plug it in for x. So you would do 0 squared plus 4, which is 4. So the limit of x squared plus 4, as x gets closer to 0, gives you an answer of 4. Not a big deal. That's not an issue. But now if I ask you to calculate the limit as x approaches 4 of g of x, now we're using the second rule over here, the square root of x. Notice it just says the square root of x. It doesn't say the positive and negative square root of x, so we are only concerned with the positive answer. So the limit of g of x is equal to limit as x approaches 4 of the square root of x, which really means that you are just taking the square root of that value. Square root of 4 is equal to 2. So we have an answer of 4, and we have an answer of 2. You with me?
Yeah.
All right. So now, going back to the definition that we were all confused about a moment ago, this is what it's going to say. What is the limit as x approaches 0, of g of f of x? What that really means is you take g of this thing right here. Well, what is the limit as x approaches 0 of f of x? What did you get? You got 4. We just calculated it up here. So really what you're doing is finding the value of the function at 4. When I say the value of the function, I mean the value of g of x, which is right up here, the square root of x. So all you're doing is taking the square root of 4, which is 2. And the book walks you through it very, very nicely. It will ask you to find the limit of the function, it will ask you to find the limit of the second function, and then it will ask you to find the limit of the second function of the first function. Yay, math. One more example.
Wait, you,
Yes.
so for what we just did,
one? Another example very similar to it, and maybe we'll, and then I can come in and help you with visually, okay? Alright, so we have another function, 2x squared minus 10. We have g of x, which is the cubed root of x. And I'm asking you to find the limit of f of x as x approaches 3. So I'm asking you to find the limit of 2x squared minus 10. In other words, I'm taking the limit of that function as x approaches 3. This function is continuous. And if it's continuous, all you need to do is take that value of 3 and plug it into your rule. So you're going to take this 3, plug it in for x. So you have 2 times 3 squared minus 10, which is 8. Then the limit as x approaches 8 of g of x, well now we're using this cubed root of x, but this time we're approaching 8. So all you have to do is plug that 8 in, plug the 8 in for the cubed root of 8. The cubed root of 8 is 2. So we get an answer of 2. So the limit as x approaches 3 of g of f of x is by definition g of the limit of f of x as x approaches 3, which we've already calculated. The limit of f of x as x approaches 3. The limit of f of x as x approaches 3, we figured out was 8. So really what we're doing is finding the value of the function at 8. So g of x was the cubed root of x, which really means you're taking the cubed root of 8